ndimtima umo. Tiende pamodzi ndimtima umo. Tiende pamodzi ndimtima umo. Tiende pamodzi ndimtima umo. Tiende pamodzi ndimtima umo.
Good afternoon, viewers. Welcome to MTN Teleschool, yet another session. With me, your teacher, my name is Mr. Siwale Prince. I'm very much delighted to be part of this program, the revision program organized by MTN Zambia. And today I'll take you in Chemistry 5070. So as we start, please let's stay put and invite our family and our friends. Thank you. So I'm going to look at the first question, which is question 1. The chemical reaction below is for a reaction in which glucose is changed into ethanol. Now, before you can even start answering the question, we all know the conversion of glucose to ethanol is the process known as fermentation. So I'd want us to discuss, before answering the question, the process of fermentation. Fermentation. This is the chemical process in which microorganisms such as yeast acts on carbohydrates to form glucose and carbon dioxide. So the word equation for fermentation is just glucose being converted to ethanol plus carbon dioxide. Now, there is an important statement here in which microorganisms such as yeast, so meaning that for the conversion of glucose to ethanol, there should be yeast. So also going to look at what are other conditions necessary for fermentation. So the conditions, number 1, we need a catalyst. So a catalyst used for this purpose is the enzyme found in yeast, which is known as zymes. Number 2, we also need a temperature. We need a temperature of about 25 to 37 degrees Celsius. Now, just on the temperature, during fermentation process, if the temperature is too low, the reaction becomes very slow. Again, if it goes too much beyond 37 degrees Celsius, the enzyme that is in yeast, it becomes denatured, it is destroyed, and the reaction stops. Hence, 25 to 37 degrees Celsius is chosen as a compromise to give a good yield. Number 3, this reaction of fermentation should also be done in the absence of air. The reason why we do that is to prevent oxidation of ethanol to ethanoic acid. Otherwise, if it is done in the presence of air, there will be oxidation of ethanol to ethanoic acid. Now, let us also discuss this ethanol produced by the process of fermentation. It is impure. As such, the ethanol is purified by a certain process known as fractional distillation. Just like we know, liquids of different boiling points can be separated by fractional distillation. So in this case, ethanol obtained is impure, hence it's purified by fractional distillation. Now that we have a brief background of fermentation, we're now going to look at the question 1, which has already been read. The first question is, so the chemical equation is, let's write the chemical equation first for fermentation. The chemical equation, we have glucose, which is C6H12O6 aqueous, being converted to C2H5OH aqueous plus carbon dioxide. Remember, the formula for ethanol can also be written as CH3. This is the condensed formula, CH3, CH2OH. You can balance it in that way. So we're interested to know what term is used to describe the reaction in which glucose is converted to ethanol and carbon dioxide. Like we have already discussed, the term used to describe this process is known as fermentation. So 1A, the answer is fermentation, the conversion of glucose to ethanol and carbon dioxide in the presence of yeast. B, what is the purpose of yeast? Remember, the purpose of yeast, the purpose of yeast is to produce an enzyme known as zymes that will catalyze the breakdown the breakdown of glucose to ethanol and carbon dioxide. Okay, so that is the purpose of yeast. In that purpose, it will break down the glucose to ethanol and carbon dioxide. It acts as it provides us with the catalyst. Number C, draw the structural formula of ethanol. Remember, the formula for ethanol, it is C2H5OH. This OH, it is known as the functional group. So all alkanos or all alcohols, their functional group is OH. But the question is, draw the structural formula. So to draw the structural formula, we start with the number of carbon atoms. In this case, we've got 2 carbon atoms, so it will be 1, 2. And for each carbon, there should be a maximum of 4 bonds. So I'm going to say this is already 1, 2, 3, 4. This other carbon also has 1 bond, it only needs 3. 1, 2, 3. Remember, we have about 5 hydrogen atoms to be distributed. So we're going to put 1 here, 2, 3, 4, 5. What is remaining is the functional group, which is OH, the hydroxyl. So all alcohols who have this functional group, this is the disparate structure of ethanol. Let's now look at the next question, which is question D. To which homologous series does ethanol belong? D. The homologous series to which ethanol belongs is known as the alcohols or the alkanos. You can choose any. So ethanol belongs to alcohols or the family of alkanos. Let's look at question E. Question E reads, when ethanol is exposed to for some time, it turns sour. Explain what happens. Remember, let me just take you back a little bit. We said that one of the conditions during fermentation process is there should be absence of air to prevent oxidation of ethanol to ethanoic acid. So what happens here is if this ethanol, which is C2H5OH, is left in the presence of air and there's some bacteria, this ethanol is converted to an acid which is C3-CuH, known as ethanoic acid. Now, so that there's going to be, this process is known as oxidation. The overall process is known as oxidation. So leaving ethanol in some air, it is oxidized to ethanoic acid. And this ethanoic, being an acid, it tastes sour. However, please don't test acids in the laboratory. Okay? So if you want to test acid, you can easily just buy an orange or a lemon. There's citric acid there, and you can test it. Don't test laboratory solutions. So we can write ethanoic acid has sour taste. So that's why it tastes sour, because it is converted to ethanoic acid. F. Draw the disparate formula of the compound formed when ethanol is dehydrated. Before we can answer that question, it is important that we know what does it mean to dehydrate. To dehydrate, it simply means to remove water from a substance. Okay, so now we're told to draw the disparate structural formula of ethanol when it is dehydrated. In this case, we're going to use a dehydrating agent, which is sulfuric acid, as shown below. So this is our ethanol. So if you add H2SO4, which in this case it is a dehydrating agent, what happens? It means the water molecules will be removed from this our alcohol. So we're going to form water being removed, and an alkene is formed known as ethene. Plus H2O. Therefore, the structure of the compound formed when ethanol is dehydrated is this one, ethene. So this is ethene. It is formed when ethanol is dehydrated. Thank you very much, viewers, for watching. Remember, you're watching MTN Teleschool, brought to you by MTN Zambia. Do not forget to invite your family, friends, so that we can revise together. So we're now going to quickly look at question 2. We're going to look at question 2. The question reads, the structure below is a structure of an addition polymer. Before we get into answering the question, let's understand what is an addition polymer. Addition polymer, what is it? An addition polymer is a polymer formed when small units called monomers join. And the process is known as polymerization. So the structure drawn below is this one. Okay. I'm drawing it because I want to show you something very important. So I've got H there, CH3, H, CH3, H. Okay, now the question is saying draw the structure of the monomer from which this polymer is made. So to draw the structure of the monomer, what we do is very simple. Cut after 2 carbon atoms. So we cut like this. This structure, it is going to give us the monomer. So what we do is we write it separate, so it will be C, C, H there. Then here we're going to have CH3, H, and H there. So now, to draw the structure of the monomer, what you do is get a repeating unit and add another bond. So this is the structure of the monomer with a double bond. And we should know that for polymerization to take place, there should be this property or feature, double bond. This is the feature that enables addition polymerization. The question reads, what is the name of the monomer? So, the name of the monomer, we recognize that there is a double bond on this monomer. It being a double bond, it means it is an alkene. So we should also know how many carbon atoms are present. Let's count them. 1, 2, 3. So since there are 3, this becomes a prop. The type of bond present is double. If the type of bond present is double, the middle part becomes En. What is attached is just hydrogen, so it becomes a propene. So the name of the monomer is known as propene. We can now look at question C. The question reads, suggest the name of the polymer. So we go back. So this polymer drawn here, it is made from propene. We should know that whenever an alkene polymerizes, what we form is a polyalkene. So, in this case, our monomer was propene, meaning that the polymer becomes polypropene. So the name of the polymer in this case is polypropene. We can now look at question D. Suggest two differences between the monomer and the polymer. So to do that, I want us to draw the structures now of the monomer and the polymer again, so that we're able to differentiate. So this is polypropene. Polypropene, H. So this is our polymer. Let's also draw the structure of the monomer, which is polypropene. Okay. Now, let us deduce the differences. We recognize that our polymer, which is polypropene, they are just single bonds throughout. So because they are single bonds, we can say that our polymer, number one difference is the polymer is saturated, meaning that it is single bonded. It has single bonds. Well, remember when we are differentiating, we are comparing between the two. Now, when you look at our monomer, it has got a double bond, so that's another difference. So the polymer is saturated while the monomer is unsaturated, meaning that it has got a double bond between its carbon to carbon atoms. Okay. Okay, so that is one difference. We have observed the polymer is single bonded and the monomer is double bonded. This is our monomer. Number two, we recognize that this, our monomer, when we check even the number of carbon atoms in our monomer, they are very few compared to our polymer, meaning that the relative molecular mass of this, our polymer, is going to be greater compared to the relative molecular mass of the monomer. So we can add also to say the relative molecular mass of the polymer is greater, while that of monomer is smaller. So also we can add this our monomer, it is a gas, while the polymer, it is solid at room temperature and pressure. So polymer is a solid at RTP, room temperature and pressure, while the monomer is a gas. We can now look at the last question, which is E. The question reads, state one similarity between the monomer and the polymer. We observe here that both the polymer and the monomer, they just contain two types of elements, and these elements are carbon and hydrogen. Such elements are classified as hydrocarbons. So we can say one of the similarity we can say both the monomer are hydrocarbons. And remember, a hydrocarbon is a compound that contains carbon and hydrogen only. I've underlined this word only, meaning that those compounds which do not have carbon and hydrogen only will not be fit to be classified as hydrocarbons. E.g., if we have C2H5OH, this one is not a hydrocarbon because it has OH. Hence, hydrocarbons should just have carbon and hydrogen only. Viewers, thank you very, very, very much for watching, and thank you very much for your support. Remember, you're watching MTN Teleschool, a program brought to you by MTN Zambia. Remember to invite your friends, your families to be a part of this revision program so that together we can be very much prepared for the October and November examination. Very shortly, we're going to go on a short break, and we'll be back as we finish this revision process.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama nizingono, or nizambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tiloa.
Cause cash money yeve across Zambia.
Tituma. At Basi and Kuchipata. The end of South Africa. Hello, what?
Run, K-Star, run! You got the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN, everywhere you go.
Hello! This is all you need to know about data bundles. Like when you need airtime to make calls, you need data bundles to browse the internet, send and receive photos on Facebook, chat on WhatsApp, send emails, listen to music, and many other things. Data is measured in bytes, kilobytes, megabytes, and gigabytes. These are a bit like money, and just like your bank balance, your MTN account has a data balance that you can use to buy data bundles ranging from 5 megabytes to 20 gigabytes for daily, weekly, and monthly subscription. To buy a bundle, dial *335*1#.
From sending emails to browsing or watching online videos, many of the things you use depend on your device's functionality and network capability. Entry-level devices have limited data usage, whereas smartphones and computers have limitless data usage. The longer you spend online, the more data you use.
Sometimes you feel like your data is running out really fast. That's because today's modern technology and higher definition content require and use up a lot more data. No need to worry. Data can be managed to work for you by minimizing on the number of apps that automatically update themselves and turning off your data when not in use. Make sure you use data bundles to browse the internet. When your bundle is depleted, you will be billed from your airtime. Perform regular data balance inquiries by dialing *335*3#.
Gimbari Annie, thank you very much for your like. John Green, thank you very much for your support. Continue supporting us. Okay, we'll now quickly go into a continuation of our revision program. Okay, welcome back. So we're now going to look at question number 3. The structures below show 3 organic compounds. There's A, B, and C. The first question is, name each of the compounds A, B, and C. Now, we're not just interested in naming those compounds. We want to know, how do we name them? So I'll show you a series of steps that are going to be used in naming these compounds, such that should you come across any other compounds apart from this, you should be able to name. Okay, so we're looking at question 3. So we'll start with some basic rules naming compounds. The first thing that guides us to name a compound is the number of carbon atoms. So first name. So to know the first name, we consider, the first part of the name. We consider the number of carbon atoms. So, number of carbon atoms. Name, beginning. So, if the number of carbon atom, if you have just one carbon atoms, the name beginning becomes a meth. 2 carbon atoms, it becomes eth. 3 carbon atoms, it becomes a prop. 4 carbon atoms, it becomes a but. 5 carbon atoms, it becomes a pent. 6 carbon atoms, it becomes hex. Now, for this revision purpose, I will just end on carbon number 6. Otherwise, they can continue going. So now, the second part, which is known as the middle part, the middle part of the name, for this one, we consider the type of bond present. So, type of bond, the middle part, if the type of bond present is single, the middle part is going to be AN. If the type of bond present is double, the middle part is going to be EN. So by single, something like this. Double. Okay. If it is triple, the middle part, so these are triple bonds, the middle part is going to be YN. Then the last part is what we consider the name ending. So this one we consider what is attached. So, what is attached? Name ending. If what is attached is hydrogen only, the name ending, it will be just E. If what is attached is hydroxide or hydroxyl, which is OH, what is attached is going to be OL. I mean, the name ending becomes OL. If what is attached is the carboxyl group, which is Kuch or this, the name ending is going to be OIC. So having known the procedure on how these compounds are named, let's go back and name our compounds A. So we have C there. So let's consider the first part. We're told we consider the number of carbon atoms. If the number of carbon atoms is 2, it means the first part of the name becomes ETH. If the type of bond present is single, we are told there that the middle part becomes AN. So this becomes an ethane. Also, we consider what is attached. In this case, if what is attached is a hydroxide OH, hydroxy with the name ending becomes OL. So this is ethanol. So that is how we name the compounds. So A is ethanol. Let's look at B. Okay. For B, I'm not going to use the rules. That's an ester. Okay. So we recognize that this compound is an ester, just like you can see, this is an ester link. But how do we name this compound? So what guides us is the number of carbon atoms attached also. So in this case, they give us the alcohol that contains 2 carbon atoms. It is known as ethanol. So meaning the alcohol used to make this was ethanol. And these other carbon atoms, they'll give us the acid used. So the acid also that contains 2 carbon atoms is known as ethanoic acid. So these are the 2 substances used to make this compound here. So there was a reaction of ethanol plus ethanoic acid. Now, when these 2 react, this alcohol, the ANOL, it is removed and we add YL. Then the OIC is also removed, we add OATE. So the reaction is reversible. These together, when they combine, they form an ester which is known as ethyl ethanoate. So that is our compound B. Its name is ethyl ethanoate, an ester. Let's look at compound C. C is okay. Remember also, there are 2 carbon atoms. If there are 2 carbon atoms agreed, this becomes an F. The bonds present in this case, like you can see, these are single, so it will be ethane. The last part of the name, we consider what is attached. So this, we know it's a carboxyl group. So it being a carboxyl group, meaning this is an acid, and the name ending, like we discussed, it is going to be OIC. So this is known as ethanoic acid. Let's move on as we look at question B. Give the term used to describe the type of reaction occurring when compound A is converted to C. So changing A to C, remember A, it is ethanol, being converted to C, which is ethanoic acid. So the process is known as oxidation. So that is our solution. When ethanol is converted to ethanoic acid, the process is known as oxidation. Let's look at 2. We're converting, when A react with C to form compound B. So remember, our A is ethanol reacting with ethanoic acid, forming B, which is ethanoate. The process in which an alcohol reacts with an acid to form an ester and water is known as esterification. So in this case, the process is esterification, which A and C react to form B. We can now look at question C. The question reads, when concentrated sulfuric acid is added to compound A, a reaction occurs and a colorless gas is formed. Draw the structural formula of the organic compound formed. So, compound A when it is treated with sulfuric acid, it is going to form a compound which has a double bond, which is known as ethene. So this is the structure. So this is the structure of the compound formed when ethanol is treated with sulfuric acid. Ethanol is dehydrated to an alkene, which is known as ethene. Let's look at the last part of the question, which is C2. State one important use of the organic product. One important use is it is used to make plastics such as polyethylene. That's one important use of the organic product. It is used to make plastics such as polyethylene. Okay, we're done with that question. Remember, you're watching M10 Telescope. Invite your friends and family. Let them like our page and we revise together. Let's move on to the last part of the question, which is question number 4. The question reads, the diagram below shows 2 monomers which are used to make nylon in the laboratory. So their structures are drawn below here. So the monomers will have 1,6 diaminohexane, and we also have the other monomer there, which is an acid chloride or hexane dichloride. Okay, so the first question is, what term is used to describe the type of reaction in which nylon is formed from the 2 monomers? Remember, we discussed the 2 types of polymerization. There's addition polymerization, which we've already discussed, and the other type is condensation polymerization. It's a type of polymerization in which a polymer is formed by elimination of small water or ammonia or hydrogen chloride molecules. So in this case, the type of polymerization is condensation polymerization. Okay. Let's look at B. Apart from nylon, name another compound formed from the reaction of two monomers to form nylon. So apart from nylon, what else forms? So what forms there is very simple. We react a hydrogen, we react with the chloride. These two, when they react, they'll form what is known as HCl, which is hydrogen chloride gas. So what else is formed is known as hydrogen chloride. Okay. We can now look at question C. Draw the structure of nylon showing 4 monomer units. So to do that, what we do is very simple. We're going to use the same monomers given in the question. So we can start with 1,6 diaminohexane. So to come up with our structure. After writing 1,6 diaminohexane, we also write hexane diol chloride. After doing that, we have been told 4 monomer units. So we continue to add the monomer units. So after this, we write now diaminohexane. After this, we can now look at again, we add an acid chloride, which is hexane diol chloride. Okay. Okay, very good. So now, want to form the structure for nylon. What we do is this. This hydrogen from diaminohexane, it will react with the chloride from the acid chloride. Again, this will go with that. Again, this reacts with that. And this is also going to go with this one. So what we do is we eliminate the hydrogen chloride and see what remains. So we're going to have this. Remember, the hydrogen has been eliminated. We remain with NH there. Here we're going to have NH. The hydrogen has also been eliminated. We're going to have C, double bond to O, to another unit. This to carbon, double bond to NH, another unit. N there, H, C, H, O, another unit, C, double bond to O. We are done. So this is the structure of nylon, showing 4 monomer units, 1, 2, 3, 4. So we're done with this part of the question. Doing this, you get yourself 2 marks. Now, we can look at question D, which is a baby to question C. The question says, draw a circle around the simplest repeating unit in the structure you have drawn above. So remember, a repeating unit is formed after two monomer units have reacted together. In this case, we have that here is the point where the reaction of one repeating unit was. So it is going to be this up to this point. So this one is a repeating unit for nylon. And remember, a repeating unit has two monomer units. So this is question D. So for question D, that is the repeating unit. Let's also look at question E. Name a naturally occurring macromolecule which has similar linkage to those found in nylon. What name is given to this type of linkage? So the name of the macromolecule is the similar linkage to that of nylon is known as a protein. Remember, there are about 3 natural polymers that we discuss under our 50/70 curriculum. That is a carbohydrate, a protein, and a fat. A protein has a similar linkage to that of nylon, and a fat to that of tediline. But today we're interested in that of nylon, which is a protein. So the name of the macromolecule is a protein. The type of link is known as, it is this one here. So this is a link in nylon and protein, which is known as an amide. This is known as an amide link, or you can also call it peptide linkage or link. So the type of link is peptide link or amide link. We can now look at the last part of the question, which is question E. State one use of nylon. So this nylon, it is used to make, there are a lot of them, can be used to make fishing nets, ropes, bags, and so on. You can pick any one of those. Thank you very much for being part of this revision program brought to you by MTN Zambia. Please catch us next according to our schedule as we look at more revision sessions in chemistry tomorrow. Thank you very much. Good day.
Tiende pamoja ni mtima umo. 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 Tiende pamoja ni mtima